One, two, one, two, one, two, one, two, one, two. Woo!
Hello guys and welcome back to this one. So today we'll be looking at the debugger tool, and for this solution I believe this debugger tool is like the best guy to basically show us everything. I believe for me, like it best brings home the idea of what the parent pointer is trying to do, more than the code revision and more than the graphical illustration. But yeah, I think the graphical illustration has been winning the day up till now, but I think for this one the debugger session takes the cake. So just get into it and see how it works. So so obviously we know that we have our node defined, and basically we've run our debugger tool to define the node, see what's current is holding, define prev and hold a none to it. Now current is pointing to a node, and so we can start transversing. So we step in. So in the first instance, we check if prev is equal to the parent, which is also actually none. So we should be able to see what the node is holding, or the current rather is holding at this point. So what the parent is pointing to none. So you can step in. If current or left if it exists. So current dot left, you could see here that current dot left holds a value. So that means we can transverse. So we say if previous is equal to this is equal to now current is equal to this. So we are pointing previous now to the head of the node. So basically we have this here where previous is moving from here. Now current is here. So we are now having previous move from being none now to being a guy over here. So we continue in that same vein as we now continue to iterate. So we move current to current on left. So we see that previous has become a new man, and current has now gone to become a new man of his own as well. So we see change. Now current becomes a new man. But yeah, so we go back to the top of the tree and we check if the current exists. So obviously to graphically show it, we could see that yeah, this guy over here, and then we have this guy over here. Now we then carry on. We drop again and we check if current is this, because the we see that previous is still the parent of the current, right? So we would have the same iteration. The current is called left is existing, previous becomes current, and current becomes current or left. So we go to the top again, right? Now parent is at the okay, sorry, let's see what we're having here. Okay, current is at 1, right? Current has now moved to 1, right, from our illustration over here, which is previous now, and then current has moved to 1. So yeah, just to give that graphical feel again. So but yeah, we check it again. Now current, we now step in again. Is current a value? Is previous equals to current parent? That's true. So but is current or left, does it exist? I don't think it exists anymore, so we have to jump over that guy. So now we print out current for the first instance. So we see our print is done. I believe if we have this up, we should be able to see it just prints it out. Let me see. I don't need to the debugger console is up. Okay. Okay, I think this should be it, if I'm not mistaken. Yes, so we have one printed out. So yeah, we have one printed out. So that's the one that follows the debugger console, or the debugger tool. So we could close that for space, and then we go down again and we see that we now make prev, current, and current equals to current on right, just as we saw in the debugger tool. So um, we do that, and basically the values update. We could see the value update for current is now 2, and we see that the previous is still 1, so it's still down to the left. So we move again, we see that our previous is current or parent, and okay, so we see that this block does not hold any water anymore, because if previous equals to current ahead, so that does not hold water anymore, because previous is now 1 and current is now 2. So basically previous is equals to current left, which is what is true. So we can then iterate, right? We can now go come to this block and step in. So we have to print out this guy. So when we do this, we see that 2 has already been printed out. Now we go prev equals to current, current equals to current or right. If right, the current or right, then if not current or right, if current, that's current or right, if current or right. So if current or right exists, print out current or right. Or sorry, move current to current or right. But if not, move current to the parent. So let us look at current. Why we go through this. So prev now should move to current. So we see that prev now becomes 2, the them at 2, but current now has to move to the right. So when we move it, it moves to the right, which is straight. So having done that, we continue our iteration. We see that the value of current is now 3 and this guy is now 2. So this block becomes true again because now we have that 3 is 2 is the parent of 3. So we continue, but this is not the left, it's not current, is current the left does not exist. So we come and print out this guy. So we should see that come up on there. So we'll see 3 come up here and continue again. So we bring previous to 3 and then pull it up, pull current back up to 2, and we check again. Now when we check again, now we see that this block does not work. This guy also, do we have previous equals to current on left? I don't believe so. So you see that we go to the last block where we now say previous should become current, right? So yeah, so let's watch that change. So we see that previous becomes current. So they are equal again, but now current will make a move back to the parents. So where we become, where we meet 4 again, which is basically us finishing this left hand side with current with previous pointing to this guy. So you see that this way we see our previous pointing to 2 and current pointing to 4. So we are done with this left hand side. So basically every other thing we do here from here on in will be a repetition of what we've already seen. So we've seen it print out the first half of the iteration, and then every other thing from here will just be us going over the same pattern again because we built a system that print out in order. So we continue. Let's just look at the values as we transfer and we see how values change. So now we see how we are the middle block, the LC block. So we print out the current, which is 4, and we switch out current, we point out the previous to current, and then we move back up. Now we print out, we are now at current pointing to 6, pointing at 6. So we see where is our this thing, is previous equals to current. At this point, yeah, previous current, so we should step in, but is it to the left? Is current to the left? Does the current to the left? Yes, there is a current to the left. The left of 6 is 5, right? So we see that here. So we just continue again, and when we go to 5, previous becomes 6. We continue till we print out 5. Now we carry 5 to 5, bring it back to 6. Now we take it back to 6. So now we should be looking out to print out 6. 6 is printed out at this point. Now we take it to 7, take 3 to 6. Now we look at that again. Now we print out. We printed out 7 with that instance, and then we continue again, and 7 becomes 7. Now we're retrogressing, we're getting back, and eventually we're back to 4, which is the head of the node. Now we point that back out, and boom, we are done with our transversal. We print out everything we have. We are done 1, 2, 3, 4 in order, and basically that is it for the Inorder Traversal series. We've seen it get done with the Morris transversal. We've seen it get done with the stack. We've seen it get done with the recursive stack, and now we've seen the question fully answered. No stack, no recursion, no modification of the tree, and basically we use parent pointers to achieve that. So that's it for this series. Tell me in the comment section which of these solutions was your best, and yeah, and why. For me, I will leave that to the next one, on the final one where we'll talk about complexity, and yeah, I'll give you my best in that video. Muchas gracias. Auf Wiedersehen. Tschüss.